Okay, so welcome back. This is part 2 in our series where we help you develop a C++ application that, as you can see here, will do ray tracing to render an image of these spheres. And you can see it's a fairly complex scene. We got a lot of spheres, different colors. We got glass, we got reflective surfaces, we got depth of field, blurring. So it does all of this ray tracing with these different materials and objects. And we're using the code from the Ray Tracing in 1 Weekend code from an NVIDIA engineer named Peter Shirley, we talked about in the previous video. And we are supplementing that code with some additional code from an NVIDIA engineer that allows us to do this rendering on our GPU using NVIDIA's Cuda API. So we're doing ray tracing, we're using the GPU, and as a result, compared to rendering on a CPU, which might take, for this scene, in my case, like maybe 45 seconds to render this on the CPU, with GPU, it's down to maybe 4 seconds or 2 seconds. So really get a very fast render using the Cuda and the GPUs. So we showed you in the previous video how to set all that up using the NVIDIA code. In this video, we're going to address one of the limitations of that code, and that is that the code, the way it stands, renders the image, but it only saves it out to a file, a .ppm file, which is a text file that describes the RGB values of every pixel, and saves it to a text file, but it doesn't give you it doesn't bring up a window and render to the window in real time. What you see here is I've basically taken the rendered image and opened it up in a ppm viewer to see what the rendered image, but we're going to fix that in this video. We're going to show you how to do the same code, but instead we will send it to a window that comes up and renders to the window. And the goal is to use this as kind of the first step in getting to a point where we can do this all in real time and have a window that stays up. And in future videos, we'll have some GUI controls like sliders and buttons to allow us to modify the scene, like the position of the camera and the objects and the lights, in real time and update the render in real time. So in this video, we're going to do the generating a window and rendering to the window. And we're going to do that using a very nice library called Sdl. And the Sdl library basically it does a lot of functionality, but we're just going to use the functionality that allows us to send our rendered image like this to a window. Sdl, and we're also going to borrow a little bit of code from a GitHub repository I mentioned last time, and that is from Quantitative Bytes. He has a wonderful YouTube channel, multi-part series in how ray tracing works in C++, and we're going to borrow one of his classes called a QB image class, and it turns out that really fits in nicely with our existing code, Ray Tracing in 1 Weekend with Cuda, and we can just add his QB image class code to this project. And it's fairly simple to integrate that, so it will bring up a window and display the rendered image in the window. So the first thing we're going to need to do is, you can see here we've got our simple project that we developed last time, and it's only got a bunch of header files, C++ header files, and the main.cu, which is the main Cuda code that actually runs everything. And we're going to add the QB image. You see here qbimage.cpp and qbimage.h from the Quantitative Bytes. So how are we going to do this? Well, Sdl is going to be the primary library we're going to have to deal with. So the first thing we're going to have to do is we're going to have to go to the Sdl Simple Direct Media Layer website and download the latest version. And you can see it's at libsdl.org. So to download it, you can see Sdl version 2022. We're going to scroll down to the development libraries. And we're doing this on Windows. We're going to use Visual Studio. and we're going to use Visual C++. So we're going to click on this zip file and we're going to download it to our hard drive. So now after you've downloaded the zip, and here's the zip I've downloaded, SDL2 Win32x64.zip, I just unzip it and I come up with this folder here, and I renamed it. It's got a long name, so I just named it SDL2. So once I've got that, you can see I've got all of the docs, the include files, and the library. So all we have to do is tell the Visual Studio project the path to all of these files, okay? And if you've ever done Visual Studio before, you know how to do that. It's pretty straightforward. What we'll do is we'll go into Visual Studio and I'll briefly show you how to do that, but it's basically letting it know where these things are. So here we are with our project, and I'm going to go up to the project. I'm going to right click. I'm going to go to Properties. So the first thing we're going to do is set the directory path. So we go to Visual C++ Directories, and there's two sets of directories we're going to have to set. We've got the include and the library. And here is the include directories, and here is the library directories. So I go to include, I go to the drop down, go to edit, and I've added the path to my resources SDL include. So find your SDL2 include and add it there. Okay. The next one, as I said, is the library path. Go here, edit, go to SDL2 lib x64. Make sure you select lib and x64. And that's that. The next thing we're going to have to do is for the linker. And we're going to go to input under the linker. And you can see I've got additional dependencies. So I'm going to click on that and I'm going to edit. And all I've done is I've added these two top entries into the dependencies. And all I'm doing is I'm going in here for the lib x64 and I'm giving it the sdl2.lib and the sdl2main.lib. I'm adding those to the dependencies, and I've just added them in here. And that's it. So you should be pretty much set. One last thing you're going to have to do is go into the environment variables. So just go down and run environment variables and set a path to this lib64, all right? So in the Windows environment variables, you just, in the path, you just set a path to lib x64, and you should be all set to go. So now we've got SDL set up. The next thing we're going to have to do is we're going to download the two files, the QB image H and the qbimage.cpp from Quantitative Bytes GitHub. So first we'll prepare our project to receive these two files. One's going to be a CPP or C++, and one's going to be a header file .h. So I'm going to click on my project again and add new item. And as we did before, you can add one CPP file, call it QB, as you see over here, lowercase qb, uppercase image.h, and one, the same thing, .cpp. So we'll have two blank files that we can just copy and paste from the website. So when you've got those two, we will go to GitHub, to this github.com Quantitative Bytes. And here is the website. And we're going to scroll down. We're going to go to QB Raytrace 2 and click on that. And here you will see the code, and we're going to go into the QB Raytrace folder, and we're going to copy and paste only two files, the QB image CPP and the QB image.hpp. Now I tend to name my header files .h, and he uses HPP. So when you do this, you're going to have to make sure you're using the right suffix, whether H or HPP, but I just changed mine to H. So we go into, let's look at HPP, and you've got some stuff here, and you're going to be including the SDL.h file, and you're going to want to make sure that's correct. And really it's just a constructor destructor for the class, the QB image class, and doesn't have a whole lot here. And then we're going to go into the qbimage.cpp, and it's got a bit more code. And qbimage.hpp, you're going to want to make sure that that's H if you're using H. And everything else is pretty much good. There's one thing we're going to change since we're using Windows. This is written for Linux. This down under the byte order SDL Big Endian. The byte order on a Windows machine is Little Endian. So you're going to have to go down to this line 153 and change the B to an R and the R to a B. So it should be RGB. Otherwise, just copy and paste those into the blank CPP and H files, and you should be good to go. So here I am in my project, and I've got qbimage.h that I copy and pasted. You can see I changed this include to make it match what I'm using, sdl.h. And basically everything is the same, and I'll go to qbimage.cpp, and this just wants to be initialized, not a big deal. And like I say, everything is the same, but if you go down to, in this case it's line 130, I've set it to R, G, and B. And otherwise you should be all set. So when you've got those copied and pasted, and you make sure you've got the right .h and the right references to SDL, you should be good. And here is our very simple project with the main.cu and the qbimage.cpp and qbimage.h. So now what we're going to have to do is go into main.cu. We're not going to change anything else here in the ray tracing in one weekend. We're not going to change any of the code. We're just going to change the main.cu to use what we've got. So here's the main.cu, and I've added some documentations. I'm going to drop that. The only thing I've added in the includes is this qbimage.h. So add that to make sure you're referring to the qbimage. And everything else, I've collapsed all of these Cuda functions, check Cuda, vec3 color, void rand init, render, create world, free world. And all I'm going to do is I'm going to change some stuff in the int main. Okay. The first thing I want to change is the way you've got it is probably blank in these parentheses. Type what I've got here, which is int argv, comma, char star star args. And then everything I've got between the lines with the asterisk is going to be new code. The first thing I'm doing is I'm setting up Sdl. And I am instantiating a qbimage class, and I'm calling it mimage. I'm setting a bool is running equals true, and that's going to be for our endless loop to keep this process running. And when we want to get out of it, we set that to false. And then I'm setting some Sdl requirements where I'm defining an event, which is basically when you're running the Sdl window, if you click the X in the window, it's going to send an event and end the program. And then I am sending references to the window and the renderer. The window is basically the main window, and the renderer is kind of a sub-window that we render the image into. All right, so I'm instantiating those and setting them to null. And then I am doing an if Sdl init, and I'm saying Sdl init everything is less than 0, return false. So that basically initializes Sdl, and if it doesn't, it returns a false. Here I'm setting up my main window using the Sdl create window, and I'm calling it Raytracer, and I'm setting the parameters Sdl window position centered and centered for these two. And if you hover over any of these, you can see there's a whole bunch of information on what all these mean. So I'll leave it to you to look at those, but basically we're setting up a 1280 by 720 window. If the window setup is successful, it then goes into this if statement and set up, say, renderer, which is kind of a sub-window. And we call it p-renderer, and that is Sdl create renderer, inside p-window, and this is what driver to use. And again, you can hover over these to find out what all this means. And then m.image, which is the image class, the qbimage class, we are initializing that, and we're using a 1280 by 720, and we're using pRender as the renderer to render into. And then we're setting the background color to white using Sdl set render draw color, pRenderer and white, and then we are clearing that pRenderer. And that is the new code to get Sdl working. And then we go back to the existing code where we have a 1280 by 720 window with the ray tracing in 1 weekend Cuda, and we're using 10 samples per pixel and then 8 by 8 blocks. Now this is another few lines of code that I've added to get from Cuda. And Cuda is really good at giving you information. It's got a lot of information you can get about the Cuda devices. So I have used this Cuda get device properties to get the names of the Cuda devices that hopefully it recognizes. And I've got 2 devices, and I'm specifying a Cuda device property called devprop. And I'm saying Cuda get devices properties. I'm giving a reference to the devprop, and I'm sending to the console std error, and I'm saying device 0, and I'm getting the device property .name, and that is a parameter in device properties. It actually gives you an ASCII, if you hover over this, an ASCII string identifying the device. So pretty cool. It tells me the name of device 0. And all of these are 0 based, like everything else in programming. So my first device is 0. I've got 2 devices, so I'm giving it a 0 here. I'm doing the exact same thing for device 1 and giving it a 1 here, and it will print that out. And then we go back to the existing code. Everything else from here on is the existing Cuda code to render this. And then we go to output the frame buffer as an image, and previously all we did is we had this std out to save the file as a bunch of RGB values. All we're doing is we're adding this one line of code using the quantitative bytes QB image class, and we're using mimage, which is the instantiation of that, set pixel, and we're using the I and J values from this loop, where it loops through each pixel, IJ, and setting the pixel with that IJ value, the XY pixel value, and then the RG and B values that are calculated here, and to set the pixel. And that's it. That's all we need to do. Once we got the QB image and the SDL set up, all we need is to use the existing code and set each pixel using these IJ values with RGB. And here we're leaving the same code where it sends it out to a file. You can get rid of that if you want to speed things up. So the last bit of code we're going to add is to actually, we've set up the image, but that's just in a buffer. We need to send that out to the renderer in that new window. So we're going to use the mimage display method, and then we've got to take that back buffer and actually send it to the SDL render window using SDL render present using pRenderer, and that will actually send the render to the window. Now, it goes into an endless loop here because we've set is running equals true. So while that's true, it's just going to keep running, and it's going to wait for what's called an SDL event. And we've named the SDL event, and we're saying while SDL poll event, it basically polls SDL for any events. And while it's not equal to 0, you can see that if you hover over this, it says 1 if there is a pending event, or 0 if there are none available. So if there's no not equals 0, so if there is an event pending, it's going to go into this while loop. And if the event type is to quit, which means we've taken the SDL window and hit the X button to quit, if the event type is quit, we're going to say is running and is false. Therefore, the next time through, it's not going to go through this while loop. It's going to drop down, and it's going to destroy the renderer, called pRender, destroy the window, set it to null, and quit. So it's basically waiting after we've displayed the render. It's going to go through a loop and just wait until we get a quit event by clicking the SDL window, and then it's going to clean everything up and quit. And then we've got all the Cuda stuff where we're going to get info from the Cuda device and get errors and free everything and then reset the Cuda device. So really, it's really nice that we can just use that QB image class and use SDL. So what I'm going to do is, now that this is all working, I'm going to run this in release mode, and I'm going to hit Control F5 to run this. And you can see what we get is a printout of the two devices. And before we look at this, we got the two devices, NVIDIA GeForce RTX 2070 Super, which is my one device. My second device is a 1080 Ti, and it says rendering a 1280 image, 10 samples, took 2.6 seconds. And here is our SDL window with the absolutely perfect render. Now you look at this and you might say, hold on, that doesn't look right. The image we got on disk is this. The image we got out of the renderer is this. Well, that is one bug in this that I didn't work on too much, but I haven't figured it out yet. And we'll talk about that in a bit, but let me show you what happens. We've got this, it's in the endless loop, it's displaying the image. And if I go over here and click this, that's the quit, and now it says press any key to continue. I press any key, and now you can see we're done. So it works fine. The only problem is it's upside down. If you look through the code, you will see that in this main method here, when we get down here where we output the frame buffer as image, you can see it's going through this loop of setting the colors to each pixel value. So we're going from J equals NY, which is the number of rows in the image, or the Y value. In our case, it's 720. It's going from J equals 720 minus 1, or 719. And then it's going from I equals 0 to NX, which is it's a 1280 image. So it's going from 0 to 1280. So what it's doing is it's going from, it's going to the bottom left corner of this image and starting at 0, and it's storing all of these, and it's going from the bottom left corner up. And somehow that is causing the image to be upside down. Now, you might think that you could change this J to start at 0 and the I to start at 0. So you'd be starting at the upper left. I tried that. I used this line of code instead of this, where we're starting out at 0. That doesn't work either. So there's something going on here, and I'm not going to address that in this video. Maybe if there's somebody really smart out there, they can figure it out. But there's something to do, I think, with this pixel index. In the Cuda code, they develop a frame buffer with this pixel index. And you can see it's got this equation, comes out with a really big number of the pixel index. And I think somewhere between that and the QB image, it's generating a flipped image. Now, in my viewer, I can hit one key and flip it, but we're going to have to figure out how to make it fixed in this code. So again, I want to thank Quantitative Bytes for his wonderful code that made my life a lot easier and just happened to work perfectly here. In the next video, I'm looking to add functionality in the form of an immediate mode GUI that will give the user controls where we can modify the objects in the scene, or the lights, the positions, whatever, and get into some real-time rendering. And maybe if I get interested, I'll try to fix the flipped image, or if somebody knows an answer, they can post it down below. Otherwise, if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, and most of all, please let others know that we're here so we get some more views. I really appreciate it. Otherwise, take care. Have a really good day. Thanks.